Hey guys, so I just wanted to start with this real quick. This is Captain America. No, this is my iPod, but I wanted you guys to think about it too. Right now, this is me taking a video of me taking a video of me taking a video of me taking a video. Isn't that cool? Okay, now let me stop. Okay, now the actual story though. Today we're going to be talking about lines. Lines are pretty cool. They kind of start forever. They go forever. There's no end. There's no beginning. They're kind of eternal. And I think I drew the word lines pretty cool. So, now, we're going to go over today the equation of lines, the slope of lines, parallel lines, and perpendicular lines. It'll all make sense once we start getting over it. Now, the basic equation for lines is y equals mx plus b. Now, there's only a couple things to remember. Y is always going to be y. X is always going to be x. What these have to do is whenever you have a graph, you have a grid. It's two big long lines, and one is labeled x, one is labeled y. This is why these two have to stay the same. Now, m and b, these two numbers are going to change all the time. So, your book and the ACT are going to throw some questions at you on how to solve an equation to create a line. Let's take the example. We have 3x plus 4y minus 16 equals 0. Now, this equation is an equation for a line, but we can't set it up into a graph or our graphers yet. We have to make it equal to y equals mx plus b. Now, we do this just like any equation, yet one thing that I do want to point out is the y should remain on the left. It should remain by itself on the left. So what we're going to do is we're going to add 16 to both sides. We're also going to subtract 3x from both sides. I like doing both of these steps at the same time. So then we end up with 4y equals negative 3x plus 16. Now we have our m, which is negative 3. We have our b, which is 16. But we still have something in front of the y, our 4. So we need to get rid of that. We simply divide the whole thing by 4. Now, our equation ends up being y equals negative 3 over 4. You can leave this as a fraction there. Plus, and it's going to be plus 4. Now, we have our x remain constant. We have our y remain constant. This m, though, is supposed to interchange with regular numbers, so that way we can have a true equation. So as you can see, the m and the b change. The m and the b are incredibly important to remember. Just remember, though, for right now, the equation of a line is always going to look like this. Later on, they're going to change y to f of x, but you don't have to worry about that right now. Just remember that equation for a line is always going to be y equals mx plus b, and the m and the b can always change. That brings us to our next thing we want to worry about, and that's slope. Now, most people, when they look at y equals mx plus b, they automatically ask, why are the m and the x so close together? That's because the m is slope. I'll draw a funny line to it. But slope equals the m. Now, what does slope mean? Well, let me draw you a quick little deal right now. Slope is all about triangles. Right? We're past geometry. I thought we were done with triangles. Not even close. Now, let's say 0, 1, 2, 3, let's say this is 1 and 2. Now we basically have a graph right here. This is it. We have our x, we have our y, we have our line. Now, see how you can almost already make out a triangle in right here?
That's exactly what the slope is. That's what m equals. Now, the way to remember m or slope not slop, simply equals the rise over the run. Now, for say this example, we have a rise of 2. See, it goes up 2. At least that's where we're saying this point is. So we have going up 2. That makes it a rise of 2. And then over the run. Run is simply from left to right, because that's how you run. You run on a flat surface. So we go run is 3. So this equals y equals 2/3 x. That's because for every 2 it goes up, it goes over 3. Every 2 it rises, it runs 3. Now let's look at our last example. Our last example that we used in the equation is y equals -3/4 x plus 4. Now this one, because it's a negative, the line will be going down. Why is this? Because the way I look at it is the rise is a fall. Now you don't have to make that very technical, but whenever we do a rise, we go up, the number's positive. If we go up and right, the number is positive. But if we go, say, down and right, so it would be 2 and 3, and then 1, 2, 3, 4. Let's say we're comparing this point to this point here. We're going down 3, and then we're going over 4. We're creating this triangle, and that gives us our definition for the slope. It's pretty simple stuff, but at the same time it can get difficult just because you have to remember. Now if there's one thing that you want to really remember for slope, it's this right here. Slope is the rise over the run. Pretty simple stuff, but it's something you're going to want to jot down because it's definitely going to be on the ACT. This brings us to our third point with Mr. Potato Head here. Parallel lines. Notice how I drew the little L's to be lines. Now, Mr. Potato Head here sums it up perfectly. Parallel lines have the same slopes. Parallel lines will never, ever intersect. Because these lines are going to be going in the same direction forever, they're never going to crisscross. For them to be going in the same direction, their equation has to be pretty darn similar. Their slope has to be the exact same. So let's say this one, this top one is y equals 0.25x plus 50. Now this one is going to also have to equal a quarter or 1/4. So they can maybe write it like this to trick you up. And this b can change on a parallel line. These can be interchangeable. It can be whatever number you want. But as long as the m in the equation, because remember, our equation for a line is mx plus b, two parallel lines have to have the exact same m. They have to have the exact same slope to be considered parallel. They're never, ever, ever going to intersect, no matter what. Now, our last part is with the nutty professor. It's perpendicular lines. It looks like perpendicular because I wanted to draw a perpendicular line right here. But he sums it up as well. Perpendicular lines have negative reciprocal slopes. I'll go over that in just a second. But the thing we really want to remember is perpendicular lines will meet and make a right angle. Now we remember from geometry, a right angle is a 90-degree angle where you can fit this tiny little box in there. What does he mean by negative reciprocal slopes, though? That part we definitely want to take note of. A negative reciprocal is, I've often heard, is the opposite flip. Now, a reciprocal, real quick. A reciprocal is just the flip side of a fraction. So say we have this fraction, for example, 2/5. The flip side of that, or the reciprocal, would be 5/2. All you do is you flip it over on itself. Now, a negative reciprocal let's say we have 2/5 and we want a negative reciprocal, all we do is we take the opposite of it. So 2/5 would be 5/2, negative 5/2, or let's say we go 3/18, negative 3/18. Its negative reciprocal would just be 18 over 3. Because we're changing the negative of it, or turning it to a negative. This one was positive, so we turned it negative. This one was negative, so we turned it positive. And we just flipped the fraction upside down. For example, an equation of two perpendicular lines would be y equals negative 2/5 x plus 50, and y equals, oops, I forgot the x. Now, this one I'm going to let you guys think on for a second. The negative reciprocal. Remember, what we're doing is we're taking away the negative sign because we have one here, and we're flipping the fraction upside down. So it's going to be 2.5. Whoa, how did we get to a decimal? I just wanted to do this to confuse you. Honestly, that's what math people do. And that's what your book is going to do, and that's what the ACT is going to do as well. Negative 2/5 over x, the opposite reciprocal is 5 over 2. 5 divided by 2 is 2.5. These two lines, even though they look nothing similar, they're actually going to be the perpendicular lines. And at one point, they're going to meet to form a perfect right angle. That's incredibly important to know, and lines are honestly kind of simple. You just want to make sure you know the basics before you start anything too complex. You want to definitely know how to find a slope of a line, which is incredibly important, and parallel lines are very good to know as well. Perpendicular lines, they're important to know, but at the same time, it's not life or death situation. The ACT is going to ask you 1, 2, maybe 50 questions on this, and you're definitely going to want to know your stuff about it. So if you need any help, feel free to rewind the video or pause or take some serious notes. Also, Mr. Hemphill will be available very, very often. Will he be available? You can go to him anytime for anything.